So thank you very much for coming again. I would like to start the lecture today. So I would like to start again the notation of the lecture style. My proposal, the offering so many information in a maximum way to you. This is the planned the schedule the planned lecture IIT Campo and the IIT Bombay for the based on the collaboration. So I would like we start this lecture from November 24th and 5th, 6th. This is actually the third day, but then I'm showing the day 2 schedule. So this is the tools I'm using for you, Zoom lecture, and also the YouTube lecture, the live broadcasting, the parallelly starting. KWM, I'm still waiting with the more participants for the feedback. And now 16 the students coming, but not yet coming for the other student. So Slack may not be useful for you because of the some limited person is already entered the Slack, but some of the people are still confusing the interaction in that places. So Zoom lecture I'm offering now. So YouTube lecture. Now I learned a lot of the how to use the YouTube channel. And then I edited some redundant part. So then yesterday lecture at the opening and now YouTube. I was so surprised at the YouTube sophistication. Now YouTube automatically finds some video section. I use someone's video because of the copyright conflict. The YouTube, the studier automatically detect such a copyright issue. Then I just push the button to remove that part. For the following followers that my lecture, unfortunately, some of the part is not the recorded in the YouTube video or the recorded version, but online you can see. So I'm bit sorry for the confusion that some of the email have the wrong URL. Now I resend the email with some right URL with PIN. Okay. I received some of the multiple email for the requesting the renew the PIN, but it was not the problem the PIN. This was a problem for the wrong URL. That's why I resend again for the right position. Okay. Then now gradually people are coming to the KWM system. Then enrollment finished, and then I can feed the information back to you. Okay. I really appreciate your kind cooperation and the collaboration. Okay. This is the first message. Then please note again the Google Calendar. Please check individual the different the Zoom ID is issued in every lecture for separating for the recording video. Okay. Thank you very much for your the understanding and cooperation. So again, this is my simple message. Please join Slack and KWM. Okay. Now I resent the right way for the registration of with URL and the internet address and the PIN. Thank you very much. So this is today's lecture. I would like to start the basic lecture of the brain mechanism. I rehearsed again. I started my background as an engineer in a computer company to develop hardware design, the computer circuit, I'm also good at the software, at the programming, but also in the engineer schemes. So in that moment, I joined a new project, the new project in that moment, and to develop the personal computer, notebook computer in the first generation NEC company. I really enjoyed I was so lucky person to join. This is a kind of new scheme in that moment. So then I learned a lot of the development process. And then I also got the new ambition to learn, to know brain mechanism, then to try to implement some mechanism into the artificial machine, robot, computer. Therefore, I quit the job. So then I start to learn the mathematically the science, then got degree, then John Ricken Brain Science Institute, and spent 10 years a postdoc as kind of majoring baseball player, right? Every year I updated the contract by the production, publication. Okay, it's like a contract every year. The very tough season. So after that, so now I'm coming at the faculty position for integration of the brain science and engineering, and in the same neuro robotics. So today's lecture focusing on the 3-point view: organization, function, brain-machine issues. To know what we are, to check what is wrong or right in the mechanism, then what we can build some target mechanism in an artificial way. So I reviewed the yesterday basic mechanism, neuron. Neuron is a functional unit of network of neural network, is kind of circuit to compute any of the information inside the brain. According to the network of the neuron, you can think, you can feel, okay? You can think not only for yourself, but also someone's. This is very important for us to have such a kind of huge network of the neuron inside the brain. This is cell body, synapses, dendrite, nucleus. It's one organization life. Information collected from other units, neurons, through dendrite, such as electric voltage transmitted to the axon terminal, and information transmitted to the electricity and the chemicals, the actions. So today's topic start from squid. You know squid? Squid is very typical seafood in Japan, because Japan is surrounding is the surrounded the ocean, Japan Sea and the Pacific Ocean. So then squid is a kind of popular the animal, the living the things for us, especially in the people living in the close to the sea. It's also the famous, okay? You may know giant squid, okay? It's huge squid. It's the kind of the big mystery. Why such a big squid exists in the deep the water? Insurance point of view, again, not only the food, but also a kind of new the experiment axon I discussed about here. We try to investigate the function of the neuron. But as I said yesterday, you cannot open the scalp in someone's brain easily. That's why we want to get the neuron even from squid. Okay, squid very simple. The neurons exist, have such a the big axon. It's called giant axon. This is the one of the aspect we can simply investigate the function of the neuron. Brain insight. This is the first order neuron, second order neuron, third order neuron. That's a neural network control squid motion. That's why this living thing can live inside the sea and swim and get the fish very smart way. So then you can see such a the connection. Such a ganglion is has a network with the connecting other neuron. So then you can also extract such a specific the part of the axon from here. Then you can test such a the circuit as a very simple electronic circuit. So this is a picture in the movie. Okay, if you're trying to get the squid, you can test oscilloscope. Okay, this is the voltage axon. Okay, put needle inside. It's a microelectrode. You put the other electrode and outside the axon. Then you can check the voltage. The voltage changes. Because of the ion channel, kalium channel, and sodium channel, and short-type channel, right? This is the axonal crystal and the extracellular food. And then the channel is opening and the closing, and the ions goes into inside of the outside. So then the voltage changes. It's like this. This is the function of the neurons in the representation of the pulse. It's resting potential. It stays minus 70 millivolt and goes up to the plus 30 millivolt, exceeding a threshold level. Neuron receive the other information in a sense of the voltage and other neurons. So then it accumulated an input. So then finally, after the exceeding the threshold level, such a voltage, it goes up and down. That's why the neurons is communicating by pulse. This is the terminology. Sodium channel open, sodium channel more open, then the transition occurs. So then sodium channel is closed, the potassium channel is open, potassium channel is closed. This is a stage. This is kind of the chemical the reaction, but also the electronic potential. That's why you can test by yourself by obtaining the very fresh squid by yourself. This is the old video, 1975. Okay, that's the first. I understand this is the kind of the first stage of the test, how people extract the nervous system from the animal and test it.
The next step, of course, was the removal of a living stellar nerve, and this has now become a routine procedure at those marine laboratories where squid are studied. After the head and viscera have been removed, the mantle is cut down the middle and one half pinned out in a transparent dissecting dish. very little magnification is required to see the nerve and to cut away the overlying tissue. A simple copper sulfate heat filter cools the light, and the seawater bathing the mantle is chilled to about 4 degrees centigrade. Different scientists use slightly different procedures for the removal of a nerve. At Plymouth, Dr. Meaves first lifts the stellate ganglion and then progressively frees the nerve from the mantle. Apart from removing any superfluous tissue, no further preparation of the nerve is required before simple physiological experiments can be made. It has long been known that as an impulse travels along a nerve fiber, the active region becomes electrically negative to all the neighboring regions. 2 electrodes connected to suitable amplifying and recording devices will therefore register a diphasic change as the impulse passes each electrode in turn. The change is only produced, though, if the stimulus is large enough because, like all single nerve fibers, the giant axon has an all or none response. This is the action potential, here continuously displayed because the frequency of stimulation is high. In 1938, Pumphrey and Young found that the conduction velocity of these axons increases with the square root of their diameter, the giant axons being about 5 times faster than the small fibers. Moreover, they are graded in size. The largest, and hence the fastest, supply the most distant parts of the mantle. These giant axons thus play a vital role in the squid's life. They not only ensure that the escape response is as fast as possible, but also that all parts of the mantle contract simultaneously, an essential requirement for efficient jet propulsion.
It's very interesting. You can check the movie in the web, and also I recommend you learn if you're interested in introduction to computational science. Okay, this mechanism in giant axon is clearly reproduced by mathematics and the computer simulation. So this book very nice for even if it's a beginner. What is electric circuit? Current, potential, capacitance, electronic circuit, symbols. So then inductance, then circuit. Very nice. So then this is a circuit diagram for the battery and conductor, the capacitor and the resistor. You may know if you learned the electronics, the Kirchhoff voltage law. It's common, even in the biology and then or the computer and the machine. You can trace with that kind of the equation by yourself. More complex circuit you can test, or even the computer simulation, but also the real electronic circuit. This is a very nice book. Module finally explains. After the introduction, the basic electronical or the engineering, and then goes into the neuron, basic structure of the function. And then you can understand the mechanism of the neuron, even by mathematics. Cell body, nucleus, axon, the direction and impulse, and transmitted to the end. This clearly visualized in the graph with the mathematical formulation. It's called resting potential, depolarization, the repolarization, hyperpolarization is a 3-stage. Then it's caused by the channels, ion channels. Hodgkin-Huxley equation is very famous because Hodgkin-Huxley obtained Nobel Prizes according to this the circuit representation. It was a big mystery, the mechanism, but they are clearly reproduced by mathematics and the electronic circuits. So then explained mechanism. Hodgkin-Huxley equation, bit complex, but the structure is very simple. There are 3 components, depending on the ion channel, but some specific decay defined by alpha and beta function. So then this is the description of the differential equation in a multiple way. And N, M, H, it have the kind of dynamical the property. It controls the parameter in the side of the equation. So this is the essence of this equation. Then they got Nobel Prize. You may try to get the Nobel Prize. Of course, if possible. It's also the dream of my ambition too. So this is an actual equation, alpha and beta have some specific the property of the function of the V. Then such an injected current, if weak input, there are no responses. Some input, the input increase, the pulse, a single pulse is generated. Exceeding some of the level in the input, such a repetitive pulse is generated. This actual mechanism of the neurons or axon and from or the confirmed in the real squid axon is reproduced in the computer simulation in the mathematics. That is very amazing things. I was so surprised at this. Then you also know the state space analysis. This is also the famous or the traditional way in the system dynamics. You need to evaluate the system's stability or instability. Similarly, and we in the mathematical science focusing on the such a nonlinear dynamics. Hodgkin-Huxley linearization is the fixed point, and 2 negative eigenvalues and 2 complex eigenvalues. So then this behaves like this. This is coming very simple circuit like this. So this is the issue in the parameter. Once you try to make a model to simulate some actual phenomena in the world, even in physics, biology, or machine and control, you need to think about the variable and the parameter. Variable and the changeable, the number, the numerical, the change happening. If it's the parameter, you say, you may set some specific constant value. What is the amazing thing is that Hodgkin and Huxley, they try to specify every parameter and the variable for this with so many data and the experiment. Then finally, they had the confidence that this is the truth. That is the power of the science and the finding. That is I really envy such the achievement. Okay, PhD degree in graduate school also a kind of challenge. Not too much level for the Nobel Prizes, but similarly, it's kind of different view is obtained if you get the PhD. It's quite different master degree. Okay, master degree it's training, but the PhD a kind of outstanding work should be presented. That's why I really love for the research, and I really found for the interacting with my student in the graduate school. We are focusing on the very challenging issue all the time. If you're interested in more, okay, I simply recommend to go Khan Academy website. Khan Academy of Science and Health and Medicine nicely visualize the mechanism and the lecture. You can find the Google search Khan Academy and Neuron. Then you can find this kind of picture. Very nice. The lecture is secretly offered for you. They're free. Very nice. So go back again to my lecture. I emphasize the organization, the function, the brain-machine issue for this sense. So then what is the point, the view, why I'm emphasizing the neural network model, not for the machine learning and the deep learning. I really love music like this. This is very similar structure in neural network. Okay, neurons can communicate in real life. They play music by pulse. So single neuron are different life. They try to communicate together. fantastic. Okay. Why I use this movie? Because of this behavior quite similar the function of the neural network model. Actually, actual neurons communicating with neighbors and with some function, then they are communicating by pulse. They are synchronized together. The activity transmitted the other neurons, very sophisticated way. Music is a kind of the functional thinking. Okay, your brain generate intelligence in the form of music of neuron. So individual person has different roles in the different personality, then different creativity that emerges in the society. It's the same thing. Your intelligence coming from society with neurons in the brain. So a neuron has a different type of communication, the different spikes, and the pattern, the different bursting and non-bursting after hyperpolarization is quite silent. So this kind of the behavior, it's okay. This is the kind of the personality of the neurons. Then they try to communicate or sing a song or play instrument. So you can investigate by putting needles in the brain, the cerebral cortex, so the striatum, olfactory valve, as exists here at this mammalian brain, mostly red. So they have a different type of the firing pattern, fasting, regular firing, and others. Then we can learn some specific motion or behavior or some motion pattern, walking, running, jumping. So this is the point. I try to emphasize again the importance of mathematics. Okay. If you're a biologist, you can try to check such as the biological tissues in actually. But if you're engineering the background or kind the you are thinking about the machine and helping people, okay, mathematics helps you. So as a reference basis, and then if you're interested in the okay, what kind of such a social dynamics exists in the tiny micro the living material that you can check. So I would like to conclude this lecture today. I'm showing some specific famous crossroads in Shibuya, Japan. It's crowded, but it's not more more than the India. I the frequently visited the India, especially Campo, and people are very crowded, but the people really sophisticatedly avoid the collision. It's very fantastic. But in a sense, Japan, in a Shibuya is a famous place. It's very crowded. So first time I see the Shibuya in a real moment in a young age. I was so surprised. I was born in the northern part of Japan, the local area. The Shibuya is so crowded. People are okay, supposed to be moving, just avoiding them. This is kind of the okay social behavior, but the more sophisticated and controlled motion is also possible. This is the control behavior. The synchronize. So this kind of the behavior is happening inside your brain. This is the point I want to emphasize here. So a kind of okay, this is not only the single motion control, but also a kind of synchronization, the cooperating behavior in the group or community. Some kind of mathematics that exist for the analyzing such the coordination of the group. This is very important, some specific field, the liquid dynamics, for example. Then this is a kind of bifurcation analysis exists, or what kind of the mode exists, such as the synchronized or the coordinated motion. And then this analyzing the different type of the pattern by mathematics. So firstly, finally, I would like to introduce my short introduction. Later, this is also assignment with you in the KWM. Please check the whole video for this. Then I really want to know your impression. This is also very interesting the video, the studying on the brain plasticity in the children and the learning disability. This is also highly recommended to you to see. So they're discussing the type of the children and some specific type of the symptoms that exist in the learning disability related to the neuroplasticity. So this is the first topic I introduced at today's first lecture. Is any other, okay, is any question from the audience? Okay. So I would like to summarize today's lecture. Okay, we are living in the society and the different role, the different personality, but we are cooperating together like a brain. Okay, brain has a much more flexibility and the analytical function, and if it's sophisticated training is embedded, so then your brain can be developed more and more by this kind of manner. So is there any question again? a chat or some other places? Okay, I'll check the chat. No? If you have a question, please raise your hand. Okay, so then I hope again, then I would like to stop your stream, but I'm saying again, I'm waiting for your answer in the KWM system, and I can feedback you. Then please join the classes here. Then we can interact more. Okay. So I would like to close here the first lecture. Then the next lecture start from IST time 3 p.m. Okay. Then please take a break. Okay. See you again. Okay. Please check again the new URL, the Zoom ID that you can